Can you describe the difference between sintered and non-sintered regenerative materials?
Sure. So sintered materials are materials that during manufacturing are subjected to high heat. And these high heat is used in these other materials as a necessary part of manufacturing. So it's either to make crystals or the right size in order to be able to be used as grafting materials. But the problem is that when you sinter a product, you change the physical property of it. And what ends up happening is you lock in all of the potential good things that we see, like the phosphate groups and hydroxyl groups get locked in place. They don't want to really share ions very well. And the bigger problem that occurs is that once these things are sintered, they become ceramics. And these ceramics are very difficult for the body to break down. And instead of being able to go through a regular regenerative process, it tries to take an extreme measure and ultimately results in encapsulation in many situations. And some of these dense materials are never able to be broken down. And so that's a problem. And so on a radiograph, it's very difficult to tell because these materials are also very radio opaque, and this radio opacity never really goes away. And so you look on the x-ray 2 months, 3 months, 4 months down the line, and you say, oh, it looks like I have a lot of bone. And then you get in there to place an implant, for example, and you realize that there's still unincorporated portions of graft material that are just encapsulated with connective tissue. And where that becomes a problem is you can achieve primary stability at that point, but now long-term, that's going to be a problem. Once you've restored that implant down the line, you do not have true bone-to-implant contact at that point, and therefore all the mechanical stresses that are going to occur during normal mastication are going to stress that bone. It's not going to react very well, and then that's where we may be seeing these either moderate or medium to long-term failures. So it is a big problem. It has been identified on the medical side in orthopedics because of the vast quantities of graft materials that they use. Mm-hmm. There is documented literature of immunologic responses that are kicked off by the fact that you cannot break down these materials, and the body tries to break them down through other means and ultimately recruits what are called giant cells. And these giant cells, then when they encapsulate these products, the only place that they can take them away is through the large filters of the body, which is going to be the liver, spleen, and lymphatic system. And if you have a large enough quantity of material that has to take that route, it has been shown to cause problems potentially. So in my own practice, I don't want to make more trouble for a patient. I don't want to be the one responsible for potentially having some sort of issue happen. So I'd like to have a material that I know is, by the time that it's breaking down at 3 to 5 months, that there is very little to no crystal that's still available.
So how would you describe a non-sintered material?
So non-sintered material obviously is not subjected to high heat. The OsteoGen crystals are non-sintered, so therefore they are a lower density, but they're highly porous. And this high porosity allows for better ion exchange. And also the fact that they're not sintered, like I said, they're able to exchange ions very freely with the surrounding cells. And that is going to make regeneration much, much easier for the patient and obviously the body. So we're getting complete turnover, and the quality of bone that has been seen on histology is excellent compared to some other products that are out there.
So you would make the recommendation to other clinicians that having a non-sintered regenerative material is really important.
Absolutely, absolutely. And I think that a lot of practitioners may not understand the situation or at least understand what sintering is, or that their product that they're currently using is sintered. They just know from the physical properties that they see. Going back in at 5 or 6 months and still finding material that looks untouched, high radio opacity, things like that. And they don't really understand the mechanism behind it and why it is. And I truly do believe it's very important. And as we move in dentistry, just like we've moved in medicine, where we're looking more for biologic healing, mm-hmm. and we're looking to allow have materials that are bioactive that are allowing the body to heal itself, this is the perfect material to do that, where it's not throwing up any barriers, it's not throwing up any problems for the body to turn it over. And our ultimate goal when we are in, especially in alveolar ridge preservation, is we want to be able to regenerate bone in that site that basically histologically is no different than the surrounding bone. And that's the key. And if we can do that, then the options are open for either implant treatment or other traditional prosthetics.